Exam number 2 preparation. Use methods discussed in class lessons to solve the following problems. Notes are not allowed, and all work must be clearly shown. A non-graphing scientific calculator is okay. Here we are asked to solve the following systems of equations. In the first problem, we have a 2 by 2 system. That is 2 equations and 2 variables. Probably the simplest way to solve this system would be to do it using the method of elimination. So if I take the first equation, 3x minus 2y is equal to 5, notice that we can multiply this first equation on both sides by negative 2. And if we do that, this equation becomes negative 6x plus 4y is equal to negative 10. The second equation is the same. Now the question is, why did I multiply by negative 2? Well, the reason I did that is because we now have opposites in front of our y variable. So now if I add these two equations together, negative 6x plus 5x is negative x. These will cancel out when we add them together. And on the other side, we have negative 2. And if negative x is equal to negative 2, this means that x is equal to 2. And then we can solve for y by substituting this value of x back into the first equation. So I'm going to replace this x here with 2. And from there we get 6 minus 2y is equal to 5. Subtracting 6 from both sides, negative 2y equals negative 1. And finally, dividing both sides by negative 2, we get y is equal to positive 1/2. And so the solution here is x equals 2, y equals 1/2. For the next problem, we have 3 variables and 3 equations. To solve here, there are a couple of different methods. What I'm going to do is eliminate one of the variables twice. And the variable I'm going to choose to eliminate is going to be the variable z. So notice that if I write down the first 2 equations, we have x minus y plus z equals 4, and 2x plus 2y minus z is equal to 6. And if we add these together, you will notice that we have a positive z and a negative z, which will cancel out. And this will give us 3x plus y is equal to 10. Now what I need to do is eliminate the same variable, so the variable z, but this time I have to use the third equation. Now the z that we have in the third equation is 3 times z, so we need negative 3 times z to cancel that out. So what I'm going to do is take the second equation here, and I'm going to multiply both sides by 3. So we have 2x plus 2y minus z is equal to 6. Multiply both sides by 3. This is going to give us 6x plus 6y minus 3z is equal to 18. And the third equation will bring down. And now you can see that if we add these together, once again, the z variable will cancel out. And so we get 7x plus 4y is equal to 25. Now we're going to take these 2 equations and solve that system. Now when you go to solve these equations, what you can do here is use the same method we used in the last problem. So I could use elimination. I could multiply this first equation by negative 4 to cancel the y's. But actually, we can also use another method. If I solve for y here by subtracting 3x from both sides, we will get y equals negative 3x plus 10. And now I'm going to take this expression and I'm going to substitute it into the other equation. This will give us 7x plus 4 times the quantity, negative 3x plus 10, is equal to 25. Multiplying this out, we get the following. So remember, all we're doing here is distributing. 7x take away 12x is negative 5x. Subtract 40 from both sides. We end up getting negative 5x is equal to negative 15. And then dividing both sides by negative 5, we get x equals 3. Now once I have x, I can plug that back into here. And this is going to give us y is equal to 1. And then once we know x is 3 and y is 1, we can plug both of those numbers back into any one of the original equations. And I think the easiest one to plug it into would be the first equation. So that first equation is x minus y plus z is equal to 4. So x is 3 minus y is 1. And this gives us 2 plus z is equal to 4, which clearly means that z is equal to 2. And so the answer here is x equals 3, y equals 1, and z equals 2. In the next problem, we have a nonlinear system of equations. And so you'll notice here that in one of the equations, we have powers of x and y that are second degree, second power. So elimination usually doesn't work as well here. The better method most of the time is to use substitution. So just notice that we already have y equals 2x minus 4. So that can be substituted in for y. So if we do that, we have x squared plus y squared, and we're replacing y with 2x minus 4. And then we're going to go ahead and multiply this out. So 2x minus 4 squared means 2x minus 4 times 2x minus 4. Multiplying here, we are going to end up with positive 4x squared, negative 8x plus 16. Combining like terms, we have 5x squared minus 16x plus 16 equals 13. And now remember, to solve this, since you have a second degree equation, we need to set it equal to 0. Subtracting 13 from both sides, we get the following equation. And now we're just going to factor this, and you can factor this using a magic X if you like. But this is the factorization here. And then we're going to set each one of these factors equal to 0. Here we end up with x equals positive 1/5, and here we end up with x equals positive 3. And then we have to find the corresponding y value. So if x is equal to 1/5, y is going to be, plug it into this equation here, 2 times 1/5 minus 4. This is 2/5 minus 4. And that can be written as 2/5 minus 20/5, which is negative 18 over 5. So our first solution is 1/5 negative 18 over 5. And then our next solution comes from x equals 3. Y is going to be 2 times 3 minus 4, which is 2. And so the second solution is x equals 3, y equals 2. In the next problem, it's very similar. We have y is equal to x squared minus 3. We're going to substitute that into the first equation. This will give us x squared plus x squared minus 3 quantity squared is equal to 9. Like in the previous problem here, we are going to multiply this out. Multiplying x squared times x squared is x to the 4th. X squared times negative 3. X squared times negative 3 again. And negative 3 times 3. And we end up with x to the 4th minus 5x squared plus 9 equals 9. So again, here I'm just combining like terms. But then when you subtract 9 from both sides, you get x to the 4th minus 5x squared is equal to 0. And to solve this, I'm going to factor out the greatest common factor, which is x squared. And then I'll set x squared equal to 0 and x squared minus 5 equal to 0. If x squared equals 0, this clearly means that x is 0. For the second part here, we have x squared is equal to 5. And then we're going to take the square root of both sides to get x is equal to plus or minus the square root of 5. Now, to get the y values for these points, again, you're just going to plug it into the equation here. So remember, y is equal to x squared minus 3. So if x is equal to 0, y is going to be 0 squared minus 3, which is negative 3. So that gives us the point 0, negative 3. If x is equal to the square root of 5, y is going to be the square root of 5 squared minus 3. And this is 5 minus 3, which is 2. That gives us our second solution. And finally, if x is equal to negative square root of 5, y is going to be negative square root of 5 squared minus 3. And this is also 5 minus 3, which is equal to 2. And so we have three solutions here. And that's it. Next, we have an application problem. The sum of the squares of two positive numbers is 106. Their difference is 4. Find the numbers. So first of all, let x and y be two positive numbers. What we know about x and y is that if we take the sum of the squares of those numbers, we get 106. And the difference of those numbers is 4. Okay, so x squared plus y squared must be 106, and x minus y must be 4. Now to solve this, probably the easiest way to do this would be to, once again, use substitution. So notice in the second equation, if I add y to both sides, that's going to give us x is equal to 4 plus y. And then I can take that expression and I can substitute it into the first equation, which is going to give us 4 plus y quantity squared plus y squared is equal to 106. Multiplying this out, we get 16 plus 8y plus y squared plus another y squared equals 106. And so I am multiplying this out like I did in the previous two problems. And this leaves us with 2y squared plus 8y plus 16 equals 106. So I'm combining like terms here and reordering the terms. Now let's set it equal to 0. So I'll just subtract 106 from both sides, which gives us 2y squared plus 8y minus 90 is equal to 0. I can factor out a 2. And then we can factor the remaining fairly simple. So negative 45 is positive 9 times negative 5. This will work. Now setting y plus 9 equal to 0 and y minus 5 equal to 0, the first one tells us y equals negative 9, and the second one tells us y equals 5. But y can't be negative 9 because they tell us the numbers are positive. So y is 5, and if y is 5, we know that x is equal to 4 plus y, so that's going to be 4 plus 5, which is equal to 9. So the answer to this question, what are the two numbers? The numbers are 5 and 9. Next, we have a partial fraction decomposition. So in the first problem here, we have 8x plus 1, and the denominator is factorable. It is going to be x minus 3 times x plus 2. So what we have down here is the product of two linear factors. So we know that we can use a partial fraction decomposition like so. So now we need to solve for a and b. What I'm going to do is multiply both sides by the least common denominator. Now on the left-hand side, when you multiply, it simply cancels out and we get 8x plus 1. On the other side, when you multiply this by this, the x minus 3 is going to cancel, and we will be left with a times x plus 2. And when you multiply here, the x plus 2 cancels out, and we are left with b times x minus 3. And the easiest way to get a and b is to let x be equal to a number that will make one of these factors 0. So let me start by plugging in x equals 3, since I know that 3 minus 3 will be 0. If I plug in 3 here, we get 8 times 3 is 24, plus 1 is 25. On the other side, if I plug in 3 here, we get a times 5. And of course, when I plug in 3 here, we get b times 0. So we get 25 is equal to 5a, and that means that a must be 5. And then to solve for b, I'm just going to do the same thing. I'm going to let x equal the number that makes this factor equal to 0, which would be x equals negative 2. When we plug in negative 2 here, 8 times negative 2 is negative 16, plus 1 is negative 15. When we plug in negative 2 here, we get a times 0. Plus, when we plug in negative 2 here, we get b times negative 5. So this tells us negative 15 is equal to negative 5 times b, and dividing by negative 5 on both sides, we get b equals 3. Now once we have a equals 5 and b equals 3, remember that's not the answer. You have to plug those numbers in. And so the partial fraction decomposition here ends up being this. Now in the next problem, what we have here is a linear factor in the denominator and an irreducible quadratic factor in the denominator. And so the setup is a little bit different. It is going to be a over x plus 2. And then for the irreducible quadratic, we need to express the numerator as bx plus c over x squared plus 1. Now we're going to do the same thing. We're going to multiply both sides by both of those factors. On the left-hand side, these simply cancel out. And on the right-hand side, it's very similar to the last problem. We're going to get a times x squared plus 1 plus bx plus c times x plus 2. Now what I can do is I can let x equal negative 2. If we plug in negative 2 right here, that is going to make this whole thing cancel out. Plugging in negative 2 here, let's go ahead and do that. We have 4 times negative 2 squared minus 3 times negative 2 minus 7. And then plug it in negative 2 here. And then, as I mentioned, this will go away. This is going to leave us with 16 plus 6 minus 7 is equal to 5 times a. And so this is 15 equals 5a, which means a equals 3. Now what I can do next is I can pick another value of x that would be somewhat convenient. And I want you to notice that if I plug in x equals 0, that'll make this b go away here. So let's go ahead and plug that in. Plugging in 0 on the left side is going to give us negative 7. Okay, now what happens when we plug in 0 here? Well, we know 0 squared plus 1 is 1, and we know a is 3. So we literally get 3 times 1, plus when I plug in 0 here, I am just going to get c, right? Because we get 0 plus c basically. And then when I plug in 0 here, I get 0 plus 2. So what we have is negative 7 equals 3 plus 2c. That's negative 10 equals 2c, which means c must be equal to negative 5. Now once I know a and c, I can plug in any other value of x that I want to solve for b. And to keep it easy, I'm just going to plug in x equals 1. Plugging in x equals 1 here is going to give us 4 minus 3 minus 7, which is negative 6. Plugging in x equals 1 here, 1 squared plus 1 is 2 times a is 3, so that's going to be 3 times 2, plus plugging in x equals 1 here gives us b, right? B times 1 is b, plus c. C is negative 5, so that's going to be b minus 5. And then finally, plugging in 1 right here is going to give us 3. So we have negative 6 equals 6 plus 3b minus 15. This is negative 12 equals 3b minus 15. Adding 15 to both sides is 3 equals 3b, which means b equals 1. So now our final answer here is going to be 3 over x plus 2 plus 1x minus 5 over x squared plus 1. And of course, here you don't have to say 1x, you can just say x. I'm just emphasizing that, we're plugging this b equals 1 in here, and that's why that's a 1 there. In the next problem, we have a parabola, has a focus at the point negative 2, positive 1, which is this point right here. And the directrix is the line x equals 0. And the line x equals 0 is this line right here. So that means we know that the vertex of the parabola has to be at this point. Let me put a little v there for vertex. So we know the vertex must be at the point negative 1, positive 1. And that is because the vertex is always halfway in between the focus and the directrix. All right. Now, what is the equation of a parabola? In this case, the parabola is opening in this direction. What is the equation for a parabola like that? Well, it is y minus k squared is equal to 4p times x minus h. Now, again, we know k is negative 1. We know k is positive 1. We know h is negative 1. So we can plug those in. We have y minus 1 squared is equal to 4p times x minus negative 1. And so the only thing we need to figure out is what is the value of p? Well, remember, the value of p is basically the distance between the focus and the vertex. Now, because this parabola opens to the left, we're going to express p as a negative number. So yes, it's 1 unit, but since it opens to the left, p is going to be negative 1. And so this simplifies into y minus 1 squared equals 4 times negative 1 is negative 4, and then times x plus 1. And that is the equation in standard form. And one final thing, if you wanted to see the graph, let's remember that this number gives you the focal diameter, which means through the diameter it would look something like this, and then we have the graph. Okay, you weren't asked to graph here, but that is what the graph would look like. Next, we have an ellipse that has a focus at the point 1, 5. The point 1, 5 is right here, and it has vertices at the point 1, 6, which is right there, and the point 1, negative 4, which is down here. So this is a vertex, and this is a vertex. Now we know the other focus is going to be here, right? Because if this focus is 1 unit away from the vertex, then this focus is also 1 unit away from the vertex. What we want to do is find the equation of this ellipse in standard form. So because the vertices are vertical here, we know that this equation is going to be x squared over b squared plus y squared over a squared is equal to 1. And actually, that's not quite it, because we can also see that the center of this ellipse is not at the origin. The center is actually halfway in between these 2 points, which is the point 1, 1 right there. That's the center. So let's modify this equation a little bit. It should be x minus h squared over b squared plus y minus k squared over a squared is equal to 1. For an ellipse, let's remember that a is bigger than b, and a is the distance from the vertex to the center. And so that distance right there is 5 in this case, and you could also do it down here. Okay, so we know a equals 5. We know that h equals 1 and k equals 1, because those are the coordinates of the center, which we already mentioned were 1 and 1. So we just need to figure out the value of b. Now, b is the distance this way to the co-vertices. But to figure that out, what we're going to use is the fact that the focus is 4 units away from the center, and that distance is what we call the number c. And for an ellipse, we know that a squared minus b squared is equal to c squared. And so if a is 5, we have 5 squared minus b we do not know, so that's b squared, is equal to c squared, and c is 4. So this is 25 minus b squared is equal to 16. This says b squared is equal to 9, which of course means that b is equal to 3. So the equation in the end is going to be x minus 1 squared over 3 squared plus y minus 1 squared over 5 squared is equal to 1. Next, we have the equation for a hyperbola. They want us to write it in standard form and then sketch the graph. A little different situation here. We are given an equation here. The first thing we need to do to put this in standard form is group our x variables together, and then group our y variables together. And then this negative 29, I'm going to add 29 to both sides to move that over to the other side. Next, what we're going to do is get ready to complete the square. Remember, you cannot complete the square until the number in front of your squared variable is equal to 1. So here I need to factor out 4. I'll leave a space. For the other one, I need to factor out negative 9, which turns the second term into positive 2y. And now I can complete the square. To complete the square, we take the middle number, which in this case is negative 4, divide it by 2, and square it. And that number is 4, so I am going to add 4 here. And then to the other side, I am going to add 16, because 4 times 4 is 16. I do the same thing with the middle number for the y variable. So 2 divided by 2 squared is equal to 1. So I am going to add 1 here, but negative 9 times 1 is negative 9 from the other side. So now this is 4 times the quantity x minus 2 squared minus 9 times the quantity y plus 1 squared is equal to 36. Now, to put this in standard form, remember it needs to be equal to 1 over here, so we are going to divide everything by 36. And this simplifies to x minus 2 squared over 9 minus y plus 1 squared over 4 is equal to 1. And this is the equation in standard form. And then it says to sketch the graph and label all the important parts there. So let's go ahead and do that. So the center of this hyperbola is at the point x equals 2, y equals -1, which is right there. Now the number 9, think of that as 3 squared. That tells us to go 3 units from the center to the right and 3 units to the left. And the number 4, we're going to think of that as 2 squared, and that tells us to go 2 units up and 2 units down from the center. Then we are going to make a little rectangular box, and that box is going to allow us to easily draw the asymptotes which go through the corners of that box. And then we know that since the x variable is first, this hyperbola opens to the left and to the right. So from this point on the box, it is going to open to the left. And from this point on the box, it is going to open to the right. And that is a rough sketch of the hyperbola. Now they do want to know where are the foci and where are the asymptotes. Well, you can see the asymptotes there. Well, where are the foci? So remember, for a hyperbola, the focus is going to be inside of this shape here, so it's going to be somewhere over here. We need to know what that distance is. And so for a hyperbola, we need to remember that c squared is equal to a squared plus b squared. And so in this case, c squared is going to be 9 plus 4, because this is your a squared and b squared here. And that means c is going to be the square root of 13. So the square root of 13 is about how big? Well, we know the square root of 13 is going to be 3 point something. So from the center here, if I go 1, 2, 3 units and a little bit, that focus is going to be somewhere right in there. And same thing on the other side. Okay? All right. Next, we want to find the nth term of the sequence that you can see here, and then find the sum of the first 30 terms. And then for that nth term, assume that n starts at 0, because that is the way our textbook does it. So we know the nth term of an arithmetic sequence an is equal to a0 plus n times d. So first of all, let's just observe that a0 is equal to -14. That is simply the first term. And d is the common difference. So to get the common difference, you can subtract any two terms. So you can take, say, 22, and I can subtract the term that came before it. And I think that's one of the easiest ways to calculate it here. So 22 minus 13 is equal to 9. But notice that you could have done this with any two terms. So for example, I could take 4 minus -5, which would also be 9, etc. And so the nth term, an, is going to be -14 plus n times 9. And this can be simplified to just be written as 9n minus 14. So that is the nth term. Now, to get the sum, there's a couple of different formulas. The sum of the first n terms. And one of those formulas, Sn, is equal to n divided by 2 times a naught plus an minus 1. And so let's remember in this problem, n is 30. So that is going to be 30 divided by 2 times a0 plus a29. 30 divided by 2 is 15. A0 we know is -14. And the only question is, what is a29? Well, up above here we have the nth term formula. And a29 is going to be 9 times 29 minus 14. And that is 247. And now we just need to do the math here. What is 15 times -14 plus 247? Well, -14 plus 247 is 233. And then we're going to multiply that by 15. and that gives us 3,495. In this next problem, we want to find the nth term of this sequence. This sequence is geometric. It is not arithmetic like the last problem. The formula for geometric sequence is an is equal to a0 times r to the n. Okay, so the nth term here, we need to find out, well, what is a0? A0 is the first term, which is 12. And what is r? Now, to get r, what you have to do is take any two successive terms. So I'll just take 12 and 4, for example. But instead of subtracting, we are going to divide. So I take 4 and I divide it by the term that came before it, which is 12. And this gives us 1/3. So an is going to equal 12 times 1/3 to the n. All right, now, how do we find the sum of the first 10 terms? Well, again, there is a formula for this. So we know that Sn is equal to a0 times the quantity 1 minus r to the n over 1 minus r. And so this is going to be a0, which is 12, multiplied by 1 minus 1/3 to the n. And again, we are doing the first 10 terms. So that is going to be to the 10th power. And then 1 minus 1/3. And if we round our answer here, we are going to end up getting 17.9997. And the next problem says, determine whether the infinite geometric series has a sum. So first of all, we have to find out what is the common ratio r. Again, remember, to get r, you take any two terms, dividing them. So we take the term -4, divide it by 8. This gives us -1/2. Now, how do we know if it has a sum? Well, we know if the absolute value of r is less than 1, which means r is a number in between +1 and -1, then we know it has a sum. And the number -1/2 is a number between there. So yes, it does have a sum. Now, what is that sum? Well, the formula is a0 divided by 1 minus r. So for this particular geometric series, a0 is the first term, which is 8. And then we're going to divide that by 1 minus -1/2. And this gives us 8 divided by 1 plus 1/2, which is 8 divided by 3/2. And if you do the math on this, you're going to end up getting 16/3. So yes, it does have a sum, and the sum is 16/3. Next, it says to use the binomial theorem to expand the following. So x minus 3 to the 5th power, first of all, we need to find the row of Pascal's triangle that corresponds to the 5th power. So I am creating Pascal's triangle here. I've talked about how to do this in lesson videos. But there is the row that corresponds to the 5th power. Now remember, these numbers are going to be your binomial coefficients. And then we have x and -3. So as we do this, we're going to have powers of x and powers of -3. So the way this works, of course, is we take our first binomial coefficient, which is 1. We're going to multiply that by x to the 5th power, and then -3 to the 0 power. Now the next term is going to have the next binomial coefficient, which is 5, and that gets multiplied by x to the 4th power, because the power of x has to decrease by 1 each time, and then -3 to the 1st power. The power of -3 increases each time. And the way to know that you're on track is that if you add these two powers together, you should always end up getting the original power. So the next term is going to be positive 10 x to the 3rd times -3 squared, and then positive 10 x squared times -3 to the 3rd, positive 5 x to the 1 times -3 to the 4th, and finally positive 1 x to the 0, -3 to the 5th. And now we're just going to simplify. So here we end up getting x to the fifth. Negative 3 to the 1 is negative 3 times 5 is negative 15, x to the fourth. Negative 3 squared is 9 times 10 is positive 90, x cubed. This is negative 27 times 10, which is negative 270, x squared. Negative 3 to the fourth is 81 times 5 is positive 405 times x. And finally, negative 3 to the fifth power is going to be negative 243. And this is the expansion of x minus 3 quantity to the fifth power. Next, we want to find the sixth term of this binomial expansion. So we need to know the formula for this. So to find the ith term, we need to know that it is n choose I minus 1 times a to the n minus I plus 1 times b to the I minus 1. Now in this case, n is equal to 8, I is equal to 6, right, because it's the sixth term. A is 2x and b is negative y. And so we're going to have 8 choose 6 minus 1 times 2x to the 8 minus 6 plus 1 times negative y to the 6 minus 1. Simplifying, we have 8 choose 5, 2x to the third, and negative y to the fifth. Now we need to do the math on this. 8 choose 5. You can do this on a calculator, but it's also pretty simple to do here. It is this expression, so that is 8 times 7 times 6 times 5, 4, 3, 2, 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. So 5, 4, 3, 2, 1 cancels out. 3 times 2 is 6, and we get 8 times 7 is 56. Then we have times 2 to the third power is going to be 8, and then also x cubed. And then negative y to the fifth power, well, negative 1 to the fifth is going to be negative, and then it's going to be y to the fifth. And so the only thing left to do is to do 56 times 8, and that is 448. So we get negative 448 x cubed y to the fifth. And that is the sixth term. So if you were to multiply this whole thing out, this would be the sixth term that you would see in that expansion. Next, we have an equation to solve here. This is an exponential equation. 5 to the x plus 1 power is equal to 3 to the x minus 2 power. Now, the way I expect you to do this is to take a logarithm of both sides, and I'm going to take a natural logarithm, and I want all of you to use a natural logarithm. Please do not use log base 5 or log base 3. If you do that, I'll pretty much know that you are not doing this on your own. That's what I'll say. All right, next I'm going to bring down the x plus 1 power here. And I'm going to bring down the x minus 2 power on the other side. Multiplying this out, x times the natural log of 5 plus 1 times the natural log of 5 equals x times the natural log of 3 minus 2 times the natural log of 3. Now remember, for solving for x, the next thing we want to do is get our x terms on both sides. So I'm going to subtract this term over to the left side. That will give us x natural log of 5 minus x natural log of 3. And then I'm going to subtract the natural log of 5 over to the other side. So we have negative 2 natural log of 3 and then minus natural log of 5. And the whole point of doing this is now I can take the common factor of x and I can factor that out. And then finally, I'm going to solve for x by dividing both sides by the natural log of 5 minus the natural log of 3. And then I'm just going to plug that into a calculator very carefully. And this is negative 7.4520 when you approximate that to 4 decimal places. Next, we have a logarithmic equation to solve. So let's remember when you add two logarithms together, as long as they have the same base, and let's also remember that the base here is 10, we can add these together into a single logarithm with the same base, and we could do that by multiplying these expressions together. So we get x times x minus 3. And then from here, we'll just use the definition of a logarithm, which in this case says that if you raise 10 to the first power, you get x times x minus 3. And so this is 10 equals x squared minus 3x. And if we subtract 10 from both sides, we can then factor. And then setting both of these factors equal to 0, we end up getting x is equal to 5 or x is equal to negative 2. Now notice that x cannot be 5 because, x cannot be negative 2 because if you plug a negative 2 here, you are taking the log of a negative, and that's not okay. That's undefined for us. So the only answer is x equals 5. Next, how long does a population of 30,000 take to grow to 50,000 if the annual growth rate is 5.1%? So for this, we need to know that a population P is equal to its original population multiplied by e to the r times t. So in this problem, our original population is 30,000. The population that it is going to grow to is 50,000. And the annual growth rate R is 0.051, which is this 5.1%. So if I plug all these numbers in, we get 50,000 is equal to 30,000 times e to the 0.051 times t. To solve for t, the easiest way to do this is to first divide by 30,000. This will get rid of this. And then 50,000 divided by 30,000 can actually just be simplified to 5/3. And now to solve for t, I'm going to take the natural log of the left side and the natural log of the right side. Now on the right side, this is kind of special because the natural log of e cancels, and we just get the expression here. So we have the natural log of 5/3 is equal to 0.051 times t. And then to solve for t, I'll just divide both sides by 0.051. And this gives us t equals the natural log of 5/3 divided by 0.051. And now we just need to plug this into a calculator to get the approximate time that it takes. And this is approximately 10.0, and in this case, it'll be years because it is the annual growth rate, which means years. And for our final question, we are asked to find the inverse of the following function. The best way to do this is to change f of x to the variable y. And then to find the inverse function, the first step is to switch x and y. So y becomes x, and both of these x's on the other side become y, and then solve for y. To solve for y, what I'm going to do here is cross multiply. So x times y minus 5 must be equal to 1 times y plus 1. Multiplying it out, we have xy minus 5x is equal to y plus 1. Now to solve for y, what I'm going to do next is subtract y from both sides and add 5x to both sides. These are going to cancel. We get xy minus y is equal to 1 plus 5x. These cancel. Now why am I doing that is because now I can factor out the y. And then to solve for y, I just need to divide both sides by x minus 1. And so our final answer, I'm going to write f inverse of x is equal to this function. Now I'm going to admit that instead of writing 1 plus 5x, I'm going to write 5x plus 1 because I think it looks a little nicer. And that would be our inverse function. And that concludes this exam number 2 preparation. Good luck, everybody.